So what are we going to do in this unit? In this unit, we are going to continue to take derivatives. We're halfway through taking derivatives. You have a lot more to learn. So for example, you're going to learn how to take the derivative of e to the x. You're going to learn how to take the derivative of natural log of x. You're going to learn how to take the derivative of arc tangent inverse of x, things like that. So we have those types of derivatives to learn as well. So you're going to have new derivatives you need to learn about. And in this section today, we're going to do what's referred to as implicit differentiation. Implicit differentiation. Okay, so that's our goal for the day in 3.7 is implicit differentiation. So just to kind of get us started, examples of explicit equations versus implicit equations. An explicit equation would be, say, y is equal to 3x squared minus 1. Or y is equal to, say, sine of x. Or y is equal to x minus 1 over secant of x. Okay? Those are explicit equations, and the reason why they are explicit is because y is solved for. Okay? Y is solved for. Examples of implicit equations. X squared plus y squared is equal to 25. It's that point where a teacher asks if anybody knows what shape that makes, and you hope that somebody else knows, but you are worried that nobody knows. Anybody know what shape that makes?
Circle.
Good. All right, great job. With the radius of?
5.
5, yeah. Circle the radius 5. Okay.
Thank you.
Is a circle a function?
No.
No. And so everything we've been taking derivatives so far is a function. This is not a function. Can you take the derivative of something that's not a function? Yes. The fact is you can. X times y is equal to 4. You could solve for y and then use your quotient rule or other things like that, but you don't have to. So that's an implicit equation. 2x minus 3y is 6. What shape does that make? A line, right? You could solve for it in terms of y equals mx plus b, couldn't you? And then you could easily find the slope. But you don't have to do that. You could just use what we call implicit differentiation. And then obviously there's other ones, say tangent of xy is equal to x. I hope everybody understands that in that situation, trying to solve for y would be a little bit more challenging, wouldn't it? Yeah, that would be hard. Okay, it'd be very hard. So instead of using our normal differentiation techniques, we like to turn to something called implicit differentiation. Implicit differentiation. So a quick apology to everybody on YouTube who may be watching this and then say, no, my teacher taught me differently or something like that. I apologize. I'm not great at explaining this, but I'm going to do my best. I'm going to do my best. Okay, so that means derivative. Okay, we've all learned that. That also means derivative. So when calculus was being formulated in the 1500s, you have multiple people who were kind of approaching calculus. Newton won out in many of his terminologies, but there are other teachers such as Leibniz and others who used other notation. Okay, and so this means the derivative with respect to x. Okay. This means the derivative of y with respect to x. This means the derivative of the function with respect to x. So they all kind of mean the same thing, okay? They all kind of mean the same thing. So I'm going to show you something that is not mathematically very sound, but might be able to help you understand what the heck we're doing, okay? So I'm going to take the derivative of 3x to the 4th. So the derivative of 3x to the 4th, okay? What is the derivative of 3x to the 4th? 12x to the 3rd. Everybody got that? Notice that what happened to the number of x's? Decreased by 1. So and this is where I don't know exactly how they explain this. I was never given use of that notation. It was never really talked about that much in my time. but it's becoming much more popular now. So that x reduces by 1. So you could kind of think of it like the x being absorbed up top. You know what I mean? Like what happens to that 1x? So maybe it like goes up top, you end up with 12, x to the third power. Well, what is dx over dx? 1. See how that disappears then? Everybody see that? So that's going to make sense as we do the most basic example of implicit differentiation right here. So the test that we just had, along with the stuff that we're doing now, a lot of times you see those as some of the easier questions on the AP exam, okay? And so when we're referring to implicit differentiation, you might get like 2 questions on the AP exam, and not too long, will start giving you practice questions from the AP exam for you to kind of check out and do your best with and see how you would do. So we want to use implicit differentiation to find this derivative, okay? And here's what we do. We say the derivative with respect to x of x squared plus the derivative with respect to x of y squared is equal to the derivative with respect to x, sorry about that, derivative with respect to x of 36. Everybody okay with what I'm setting up here? I'm going to take the derivative of each part. So, what do you say is the derivative of x squared? 2x. So you never have to show this. I'm just trying to teach you why in this moment. So we would say that an x kind of absorbs up there, and you're left with 2x. Yeah? What would you say is the derivative of y squared?
2y.
You would say 2y, right? And you're half right with that. We're going to show you. So we're going to say that a y gets absorbed up there. Okay? And you're left at 2y. So everybody knows the difference between those two? And then we say the derivative of 36 is 0. So let's look at what we have here. Dx over dx becomes 1. So you're just left with 2x. Dy over dx, that means the derivative with respect to y, or derivative of y with respect to x. This is a fancy way of saying the following. Y prime. Dy over dx is the same thing as y prime. Times 2y is equal to 0. So as I find this derivative, I just want to solve for y prime. So if I want to solve for y prime, what do I do to both sides? Subtract the 2x. So I'm going to go ahead here. I'm going to subtract the 2x. And I get y prime times 2y is equal to negative 2x. I divide both sides by 2y, and I get y prime is equal to negative x over y. And that is the derivative. Now, I'd like to talk, so here's the big deal. I showed you why. You never have to take that much time. The stupid way of talking about today is this, is that whenever you take a derivative of something that has a y, you attach a y prime. That's it. Every time you see like a y squared or a y cubed or something like that, take the derivative and then just attach a y prime to it. That's it. That's all you have to do for implicit differentiation. We don't like to teach it that way because there's a little bit more to it, why it works out, but that's the deal. You said it makes a circle with a radius of 6. Whoa, stop that. So you don't have to draw this, but just kind of makes sense here. We got 6, 6, negative 6, and a positive 6, so you guys can understand what's happening here with this slope. What is the slope at the point 0, 6? What's that slope? 0, right? You would say the tangent line is a slope of 0. Everybody agreed? So if you want to find the slope, you plug in the x value, which is 0, and the y value, which is 6. So everybody see it gives you 0 over 6? So that's a slope there. What would you say is the slope here? It's undefined. And notice if you plug in the point 6, 0, if you plug in 6 for x and 0 for y, notice how you get 0 in the denominator? So therefore you have undefined slope. How about the slope here? Is it positive or negative? It's positive. Notice you're in the second quadrant, so you have a negative value for x and a positive value for y. If you're plugging in a negative value for x, it would become positive on top, and then y was positive. Notice how you get positive. So this will generate the slope at any point on that circle for you. Okay? All right, so we're going to take the derivative of a few different pieces. We don't need to do this summary. You guys get it, and we're always short on time because we moved our calendar the way we did. So we turn to letter A here. You can write down 3x squared minus 4y is equal to 4x. We're going to try a number of different examples where we find the derivative today. All right, so I'm going to take this derivative. Derivative of 3x squared, you would say is?
6x.
6x. And the derivative of negative 4y. Negative 4, right? And we say that whenever you take the derivative with a y, you attach a y prime. So the derivative of 4y is negative 4y is negative 4y prime. And the derivative of 4x is 4. Okay? Now we just solve for y prime. So negative 4y prime is equal to negative 6x plus 4. We divide by negative 4. And notice how you can reduce that. Y prime is equal to 6 over 4 reduces to 3 halves. And then 4 over negative 4 reduces to negative 1. So that's your derivative. Easy? Okay, I'll let you write the second one down. It's y cubed minus 5x plus 2y is equal to 3x plus 1. What makes this one different?
There's 2 y's.
There's y's in multiple places, isn't there? And that's going to make this just a little bit more challenging, but you guys will do absolutely fine with this one. The derivative of y cubed is? Good. 3y squared times y prime. The derivative of negative 5x? Negative 5. Derivative of 2y? 2y prime. Derivative of 3x minus 1 is 3. Okay, so we talked about this last year. We actually do have kind of sequential learning in our math classes. Try to make sure you're prepared for this moment. We have y primes. We have 2 of them. Anybody got an idea for how you might want to go about solving this? Good. We're going to add the 5 and we're factor out a y prime. So I first have 3y squared y prime plus 2y prime is equal to 8. So we're going to gather all the y primes on one side. Everything that doesn't have a y prime goes to the other side. Okay? And then, in order to isolate y prime, notice how there's 2 of them. If I just simply factor out a y prime, now I just have one of them. I have a singular y prime now. And so I'll divide by the 3y squared plus 2, and I get y prime is equal to 8 over 3y squared plus 2. So when you're working with implicit differentiation, gather the y's to one side, the y primes to one side, factor it out, and divide. Okay? So I'd like you to try letter C on your own. It's x plus 2y squared equals 3x cubed plus 4y to the 4th. Why don't you try that one on your own? go through it real quick. You can check up here. So Aiden, did you not play any Fortnite?
I did yesterday.
How was it?
Oh, that was great.
I mean, people were like talking about this was the opportunity to like relive their childhood dreams.
Yo, all my childhood dreams.
Okay, all right. Good
Sure,
for you.
that's where Luis is ever home.
Okay.
All right, this is what I got. Did you guys get the same thing? Nobody got anything different?
Well, the negatives.
Did you have it switched around?
Yeah.
Yeah. So we talked about that last year. If the top and the bottom are both different by a factor of -1, then they are the same. So those are equivalent. So depending on which side you move the y primes to, you would come up with either one. So I would definitely recognize on your work which one would do. Okay. Okay, got a couple more to do. You guys have the foundation. So that's a lot of the problems. I would say this is probably the most common type of question we get on the AP exam for implicit differentiation. Okay, so anybody notice something about this? What about the XY then? What about it? You know it. You did it on the last test a lot. Nope. Product rule. Yeah, it's 3x times y. So you have two functions here. You have 3x is your f, and then y is your g function. You see it? Got to make sure you recognize that. Number one question I get from this class is people forget to do the product rule in that situation. Derivative of 3x, 3 times y plus 3x times, what's the derivative of y? 1
Y prime.
y prime. See that? Equals, what's the derivative of 5y squared? Oh yeah, we should probably do the 9x. I forgot about the 9x. Emma.
Hey, I said something.
Yeah, thank you for speaking up.
I corrected me wrong.
5y squared derivative? Good. Do you want to put your y primes on the right or the left?
Left.
Okay. Can we just go over to the right? I mean, we already got the other two over there.
Fine.
I mean, 3y plus 9 is equal to 10y y prime minus 3x y prime. What's my next step? Yep. Piece of cake upside down. Y prime times 10y minus 3x. 3y plus 9 divided by 10. Whoops, sorry, that's supposed to be a y, isn't it? 10y. Nobody spoke up. Equal to y prime. Emma.
I was writing it down.
Yeah.
Can you show how you got 3y plus 3xy? Prime.
So this is the product rule. So 3x is my f, and y is my g. So we're doing f prime g plus g prime f. So the derivative of 3x is 3 times y plus 3x times the derivative of y is y prime. So product rule. Okay. All right, we got to add a problem in here. Okay, so this next one you're going to put right here is going to be problem number 5 that we're on right now. And we're going to do x plus y is equal to the tangent of 3xy. And then we are going to do the root of x plus y is equal to 4xy. These are two separate problems. Okay, so problem 5 and problem 6. Okay. So now we're getting to a little bit more challenging stuff. That first stuff was very much just introduction. Now so these are problems that you could see on the AP exam. I've seen some of them sitting in later parts. Probably not quite as common, but let's just take it bit by bit. X plus y, what's the derivative of x plus y? Yeah, 1 plus y prime. Anybody, what do you notice with tangent of 3xy? Chain rule, excellent. So I'm going to set up the chain rule. What goes on the outside? Tangent of u. And on the inside? 3xy. Oh, so I'm going to have to do the product rule there. As you can see, your last test was about using multiple rules because often that comes up. What is the derivative of tangent? Secant squared. Remember that the rest of your life. The derivative of 3xy requires what rule? Product rule. So this is what you're asking about, Matthew. We have f and we have g. The derivative of 3x is 3 times y plus 3x times y prime. So this is going to get a little bit ugly, but I'm going to write it out. 1 plus y prime is equal to, we're going to have secant squared of what? 3xy times 3y plus 3xy prime. I got 2y primes, right? There's no good way of really doing this other than to just distribute the secant squared of 3xy to each term. Okay? So when you get here, a lot of people in their set are like, well, shoot, what do I do now? Well, we just do 1 plus y prime is equal to the secant squared of 3xy times 3y. Plus, I'll write this first now, 3xy prime times the secant squared of 3xy. I just distributed the secant of 3x squared y. Lily? Okay. This to each piece. Now can we gather our y primes? I have a y prime here, and I have a y prime there. So I'm going to bring that over to this side. I have a y prime minus 3xy prime times the secant squared of 3xy equals what remains on the other side. 3y secant squared of 3xy. What else? Minus 1. What now? Factor out the y prime. Y prime times 1 minus 3x times the secant squared of 3xy is equal to 3y secant squared of 3xy minus 1. And divide. Notice how they're almost identical. Y prime is equal to, we have a 3y secant squared of 3xy minus 1. And we have a 1 minus 3x secant squared of 3xy. Looks ugly. Very common result. Yes.
Test, like at what point, like what points would you give us, like how many points total would this be, and at like what point would you get each point?
That problem, if I were to score this, the first thing I'm looking for is that you recognize the use of the chain rule. Okay, so number one, do you recognize the chain rule? That'll be 1 point. Second of all, do you recognize the use of the product rule? That'll be a second point. And then I would give a third point either for solving for the y prime, or I'd have that be worth 2 points. So not too sure. Depends on the test, I guess. So try the next one on your own. Aaron, did you play Fortnite this weekend?
Not. Did you?
Ray, did you play Fortnite this weekend?
I did not.
Abby? Fortnite this weekend?
No.
Lily?
She did.
My brother did
She did.
all weekend. All I hear from, because we share a wall, so it's just, stop doing that! I keep dying!
So Lily played a little Fortnite too.
No, I started throwing things at the wall.
Emma?
No.
Jordan?
Yep.
Good for you.
She wasn't actually
Did
100.
you shoot a deer as well?
No, there's no
Because she
deer.
was playing with
Aiden got 2 of them. Don't say there's none of them.
Okay, well,
He
I
grew
heard-
up
I heard a
somewhere.
lot of
People were just seeing that small.
I didn't even see any. Good Bambi.
Alex, steel trap, Fortnite this weekend?
You nailed it. You got me.
Addie, little Fortnite?
Why didn't you hit it then?
Yeah. Zizi, Fortnite?
No, I didn't know it.
Taylor, Fortnite?
Of course.
Matthew?
Nope.
Allie, any Fortnite?
Yeah, but.
Melissa?
Nope.
Now I know my crowd. All right, let's check it out. Did you set up the chain rule?
Yep.
Good, way to go. So you should have x plus y and u the 1/2, 1 over 2 roots of u. Notice we don't even really explain that anymore. Derivative of this is 1 plus y prime. So when I multiply these together, I get 1 plus y prime on top, and on the bottom you have 2 roots of x plus y. Any question I got the left side? Okay, so the right side is going to be 4y plus 4xy prime. How did I come up with that? The product rule. Okay, so these start to become old hat after a while. Notice that in order to solve here, you're going to have to cross multiply, aren't you? Yeah, you got a fraction like this, you're going to have to cross multiply. So as we go through the rest of this, there's no easy way around it. You just have 1 plus y prime is equal to 8y roots of x plus y plus 8xy prime roots of x plus y. And from there, we just gather and factor and solve, right? For the sake of time, can we just let that go right now?
Yeah.
Everybody knows what to do from there. Okay. So again, distribute, teach, piece, gather. There's just no way around it. But I just want to save a little bit of time for this last question here. So please open up to this problem, letter B. It says x squared plus 4xy minus 2y squared is equal to 3. And the coordinate is 1, 1. It says write an equation for a line tangent to the following curve at the given point. Write an equation for a line tangent to the curve at the given point. Notice our first one makes what shape? A circle. What's that? No, this is the last one you want to write down. Last one you want to write down, okay? So we have x squared plus 4xy minus 2y squared is equal to 3. It goes through the coordinate 1, 1. How could I check to make sure that it goes through the coordinate 1, 1 if I wanted to? Yeah, you plug 1, 1 in, it should satisfy and give you 3. And in fact, if you try that right now, it does, okay? But so I need to write equation for line tangent. In order to write equation for line tangent, I need 2 things. What 2 things do I need? I need slope and I need a point, okay? I already know one of those, don't I? What's the point? 1, 1. That was easy, wasn't it? In order to find the slope, what do I need to do? Take the derivative. What is the derivative of x squared? 2x plus 4xy. We just did that in a previous problem, didn't we? So we used the what rule? The product rule, and we came up with 4y plus 4xy prime, did we not? Minus 4y y prime is equal to 0. Lots of times people put 3 on the end there, but you should just put 0. Now, in this situation, it's not that bad to solve for y prime, but does it ask you to find y prime in simplified form? It doesn't. It just wants to know the slope. So right now at this point, what could you plug in for x and y? You just put 1 in for each of them. So if you put in 1, you get 2 plus 4 plus 4y prime minus 4y prime is equal to 0. What happens to the y prime? They cancel. You get 6 is equal to 0.
Which is false.
I don't think 6 is equal to 0.
Exactly. So that tells us what kind of slope is there. There's no slope. It's an undefined slope. What kind of line has an undefined slope? A vertical line. What's the equation for a vertical line? X equals or y equals? X equals. And what is the x value that it passes through? 1.
Oh, yeah.
And why do we have 6? Have the
I'm just showing that this worked out to no slope. A 6 is just what this added up to. It goes through the coordinate 1, 1. Yep.
What do you want us to do?
Okay, so that first assignment in your home. Oh, here, I'll hand it back.
Oh,
Hand it back.
you
Okay?
don't have to write an equation?
I wrote the equation.
It's just x equals 1?
Oh, I'm sorry. So the slope is, I'm sorry. Thank you. So the slope is undefined, therefore the equation is x is equal to 1. Okay, sorry about that. Okay? Sorry about that. Sorry. I get confusion now. Okay, so you're ready to move on to your next piece, okay? So your next assignment is just a front and back, and it says implicit differentiation. A couple of the problems on there are a little bit more challenging. A number of them are not very challenging, okay? So that's where you want to move to next.
Huh? Pancake. Okay. Aiden, you want candy corn?
No.
Candy corn is only good if it's mixed with other stuff.
I want more candy corn.
Like when it's mixed with like peanuts? I never
Really, I'll need some more candy corn.
Yeah, it's 1 through 6, so 1 through 10.
Did you mention it?
Front and back.
No.
He'll do it at the end.
Okay, Aaron and Hattie. Or Hattie and right?
Yeah. Actually, come on, your mom's name.
Why?
Next, your next assignment on implicit differentiation. You have 6 on the front, and you have 6 on the back. Problems 1 through 12. Hattie?
So did you not need?
I did, I checked.
Oh, did you want to know how you?
Don't worry, I'll check it tomorrow.
Hey, Lily. Lily, can I have one?
Oh, my
You
brother.
just put them away.
Okay. I like strawberries.
Oh, you do? How much do you get from?
Hey, Lily,
do you have any idea what's on right now?
One of them too.
I actually do. Yeah.
And he's like, trust Thursday. I'm like, oh. Interesting. I love that. Really in class for the graph. Actually, 0. If you want to send me those answers, I'd love that, but. Oh, next time.
Monday morning, I got, later.
How can you be gone and not miss important stuff? I don't know either. So yes, the answer is yes. All kinds of population density stuff. And you have a hole in your family.
I didn't think it was too hard, it's just like a lot of information.
These are back up to core back yesterday.
I heard that, yeah.
Information.
Vega, you look very focused.
I know.
Well,
I don't understand.
Let's do that.
The first person,
Do a little buggy.
and I'd rather not.
How was the Fortnite? What do you mean? I don't play Fortnite. Do you play Fortnite?
Oh, I don't know.
I don't play Fortnite. I live to play Fortnite. That's the thing.
There?
Fortnite's not what you
400.
Fortnite's not what I do.
Higher?
Well, not as more than that.
Not too loud.
Hey, you wanna be a bag?
Oh, no, no, you want to do it.
Things like
I'm gonna
that.
do
Well, the more you drink, the more you drive.
Gentlemen, no.
It's
What up, dude?
Don't be late.
Can you sign up for the trip trip?
If you're 4 seconds late, I'm calling mom.
I didn't.
It's like
That sucks.
Alex played
I'm
Fortnite.
not going. You're gonna miss it, aren't you?
Yeah.
Grace was the flower girl and his parents.
I don't know. Maddie's here.
I haven't really heard of these.
Right until the moment.
When you were kids, you had that, he got called out and kept on a phone call, and then I see him on phone calls from you're getting past it till 15 and everyone's like, and Sam's like, what?
But she's like, I was like,
He's like, I heard people talking about that, and he said, oh, I was
and then he was like,
We don't do it.
so funny. He was so concerned. He was like,
Squirrel. The thing, squirrel. I watched the video.
Was squirrel our word?
yeah,
I think so.
Yeah.
Unless you changed it in the video.
That guy.
And it wasn't avocado either, because that's what you thought it was last time. But it was, what's the armadillo.
Armadillo.
Yeah.
Yeah. Should we really give him a treat? I mean,
Yeah.
he's home playing Fortnite for crying out
Yeah.
loud. Oh, Brian, would you like a fudge round or a Star Crunch? That's all I got left.
Star Crunch.
Man, Star Crunch, they're delicious.
Thank you.
They're really good when you freeze them or put them in the fridge.
Yeah. I think it would be fun to like kind of melt one on top of some vanilla ice cream and see how that turns out.
Oh.
That
They've
might- that
gotten
might be
smaller
the
and smaller
I know.
as the years have gone on.
It's kind of a joke.
It used
So.
to be like this.
Yeah.
Paige rocking the sick gear today. Did anybody go hunting this weekend? No hunters here this weekend?
My family did, but I didn't go with them.
Okay.
I was going to go.
Nobody shot a defenseless deer? See, Clara, I think it would be more of a challenge if the deer also had a weapon. Like,
That would be a war.
let's say
Or a
that
battle.
you were going against the deer and you got to have a helmet with antlers on it. Or the deer had a rifle.
I would rather have a set of like antlers.
Yeah.
I think it'd be fun to watch, you know?
Oh my gosh, I saw this video and it was like a deer and it like attacked another deer and it was like $2
Ooh.
but the one of the deers was just a decoy, it wasn't an actual
Oh.
deer and the head fell off and it was like, imagine that deer going and tell its buddies that like it beat up another deer
It's
so
just
bad
not,
that its
it's
head
not just
fell
deer's heads
off.
off. That would be funny. I did see, or somebody said that they put up. That's all right. Somebody said that they put up decoy deer on the side of the road sometime to see if people shoot from their cars. The DNR does to see if people are, because it's illegal to shoot from your car, right?
People do that?
Yeah. Oh, yeah. People will shoot from their car.
No, people's houses, like my aunt lives out in the country, and like houses on a road out there, like they'll have like,
Yeah.
not decoy deer, but like fake deer like in their yard or something. And every single time, no matter how many times I drive up to her house, I'll still like kind of jump. I'm like, oh my gosh, it's a deer. I'm like, oh wait, no, it's just like parked under their tree because I think it's funny to have a deer right there.
Whoa, we have